welcome to another episode of Cooking with Period 6 Mining and Exploration. No, I'm kidding. This is actually a stock pot. We're going to explain how this plays into recovering your gold today. This kind of dovetails, actually does dovetail, upon our episode 4, which was talking about macroscopic free mill gold versus microscopic, how those kind of terms get mixed around. But let's go through the process of getting the macroscopic out of your ore stream, your process sheet, or your flow sheet rather, and then down to the microscopic, which is what we're going to be talking about recovering today. Now, I will say this, don't do any of this at home. Don't try this unless you know exactly precisely what you're doing and have adult professional supervision. If you do this wrong, you will die. Your estate will sue us. They will waste their money on lawyer fees because it's going to be Exhibit 1 is going to be me saying right here on video, don't do this at home. Moving along. So, where do we start at? First, you got your ore in your mine. You blast it, you use your heavy-duty jackhammers. That's called run-of-mine ore, run-of-mine. Next step, we got to break that down. We might be talking about chunks like this. We might be talking about, if the big boy is something the size of a Volkswagen Bug or a SUV. Got to get that smaller. Actually, would never be that big, but it'd be pretty good size. So then you go to your crushing circuit. This, for the big guys, are huge gyratory crushers. Massive things that can just turn your life into a mush in 20 seconds or less. Bad stuff. For us, that means using smaller jaw crushers. We've got a little 4x6 jaw crusher right now, built into an RC46 made by Keen Engineering. It's a 4x6. Anyway, that's the primary crushing. That takes it down for us to about quarter-inch, about quarter-inch size, something like that. You can have bigger jaw crushers or two-stage jaw crushers that would go from take your something the size of a bowling ball down to 2-inch, and then your 2-inch down to 80% passing through quarter-inch size, give or take. From then you go to your grind. This is where your gold goes from being measured in inches to being measured in microns. For us, we know we need to get down to about 75 micron, which is about 200 mesh. That's usually determined by assays and roll bottle test and liberation testing to figure out where your gold comes out of your ore at. A little more technical than we need to get into today. If you ever need help on that, just shoot me a message, we can talk about it. So you got your grind. You still got now, all your ore is just really, really small stuff. What you need to do now is separate the useless rock and gangue inside that ground or it's that ground matrix from your gold-bearing minerals, or your gold and gold-bearing minerals. So you got your ore here. We're going to use gravity separation. It's easy, it's proven, we know how to work it. With gravity solely, if you are on your game, you might get up to 70–75%. The amount of time and attention it takes to get there, focusing on your mineral jigs and your shaker tables, you've got to be world class up there to get it. You're not playing with PB balls, you're playing NFL level football now. You're talking about getting 70–75%. It really is a law of diminishing returns in this case. You can really focus on using gravity to get a high level, or you can just use it to get the garbage out and then come in and do the chemical side of things. So what we got here, when you're done with gravity, you basically got a couple different streams coming out of this. You've got your macroscopic gold, what everybody likes to call free mill, but it's the visible gold. That comes off in one stream. From there, you've got your barren tailings. Now remember, gravity is all based on the specific gravity of gold. Gold is 19.1 times heavier than water, which is why gold settles out, and by putting an action, usually vibratory action one way or the other, to the feed slurry, which is the ground up ore mixed with water into a very fine mud, and then pumped through these tables and jigs. That slurry then will then separate out, give you your macroscopic gold, will give you your lighter tailings, and then will also give you your mid-weight minerals, or mid-weight minerals and other things associated with the gold, and then you'll end up with your heavies. right here, what we're looking for, we want to focus on the mids and heavies. This is where we've got gold hiding that we can't get out no matter how hard we try. It's invisible. It might be, gold might be mixed in the heavies and the mids here, or it might be bound up. It's so small that you can't grind it out. So you might have something that's 200 micron gold stuck against a piece of iron. You're never going to get it separated out. The cost of the grinding and the maintenance on your grinding materials, and it's again point of diminishing returns. Why mess with grinding it if you can hit with chemistry and get that gold out? Now the thing you need to realize too is that every ore is different, and you're going to need some testing done. Once you've got the macro gold out, collected, put it in your bucket, vial, or however much you got there, you need to test your tailings by assay. You also need to test these two together to see what your percentage is. You might be running 1.2 ounces per ton. So if you get 1.2 ounces per ton, right there, you might be getting, let's say, 0.6 is coming out with your macro gold. That still leaves you half your gold to find. What you want here is next to nothing in your tailings. You want 0. You won't get it. It'll be dang close. You might be talking hundredths of a gram or tenths of a gram, depending on how much you're pushing through. You want your tails as little as possible. You test all this by assay after you run through your gravity circuit. Then, theoretically and practically, you should have all the remaining, let's say you're going to have 0.5995 left over in your mids and heavies. So you get half your gold here, you can't see, half your gold already in pocket. So let's work on that 0.5995 to get it out, shall we? What you got to do then is get an eraser that actually works. This one doesn't. It does kind of. All right. So how are we going to get the gold out that we can't see? We've got that point. Let's call it the HM concentrates. That's a concentrated gold slurry. Concentrates. I can spell. I went to college, or I drove by one a couple times. Concentrates, which is approximately 1/2 of all your gold. What you're going to do at this point is play with everybody's favorite chemical, cyanide. When I mentioned that there early at the outset, if you do this wrong, you're going to die because you're playing with cyanide. Certain types of cyanide are highly regulated and possible to get hands on. Other types of cyanide are not regulated if you know the chemistry and how to work with it. I'm not going to explain that at all. What I'm going to say is how this process works in a general sense. So you got your HM here. For whatever reason, it's small, it's liberated, and this is only for a non-sulfide ore, a very, very low sulfide. If you have sulfides, this changes a whole lot. We might do a video on that as well. We've got your HM concentrates here. What you then do is put this into a non-reactive vessel. You can't do aluminum. You can do stainless. You can do 55-gallon drums. Plastic works very well for this. You add it. You add your cyanide, which we'll just call CN for now. And the cyanide actually attacks the gold and pulls the gold out into solution. So you've got this big, let's say, your gold solution, or your cyanide solution can probably be about 2/3 solution and 1/3 concentrate. So figure 55-gallon barrel, 15% of, or 1/3 gold, or 1/3 slurry, 2/3 concentrated cyanide. Where this comes into play is that cyanide pulling gold into solution to make what's known as a pregnant solution requires a lot of this. You got to have a lot of the O2, baby. You gotta breathe, baby. You gotta breathe. You can't just, no, you gotta have deep breaths, baby. So you gotta have a lot of oxygen mixing with your cyanide to do this. And this is all part of the Merrill-Crowe process. This was, I think, patented or came out of New Zealand in the 1890s, I want to say. One moment, cat wants to come in. Cat's in. Merrill-Crowe process out of New Zealand, and this allowed ores that were very finely divided within other minerals to be processed There was actually a secondary gold rush in California in the Comstock area of people going back and processing these tailings piles that had just tons of gold still in it and made out like bandits. And nobody really talks about that because it's not as exciting. Ooh, wow, you know, put water and cyanide on gold. Who cares? Not exciting. Well, exciting or not, it led to some very fat pockets. So you have your heavy and your mids holding the gold with cyanide and oxygen. That will then pull all the gold into solution. And you got now your barren mud basically and your gold in solution. The timeline for that, depending on your cyanide concentration, can be figure about a day, 24 hours, 48 hours to make sure. It doesn't take very long at all. The chemistry is pretty quick. Depends on temperature and some other things too. And this, by the way, is done at a pH of about 11.5. Cyanide will stay in solution fairly well at an alkaline pH. Now, alkaline is the higher numbers, 7 to 13. Well, actually, it goes a little higher than that, but we won't talk about that. Acid are the low numbers, because when you take acid, you get a very low IQ. That's how you can keep those straight. Take acid, you're stupid, you have a low IQ. Cyanide with a lot of calcium oxide, you want to run this at about 11 to 11.5 for a buffer zone. You can go a little higher. The only thing that happens is it slows it down. There's no real negative to running it at a higher pH to give you a little bit higher safety factor, but 11 to 11.5 is fantastic. Usually a good spot to do this. But don't do this at home. Exhibit number 2. So your golden solution, you got a highly oxygenated solution. You now take your gold bearing solution called pregnant solution or pregnant liquor. You pull it out, you decant it, you filter it so that you have just a pure liquid with gold in it. All the mud and everything else, you can wash it through to get a little bit of extra out. But now you've got cyanide solution. Cyanide plus your gold. You can also have silver. Silver takes a lot longer though. Silver takes about 5 times as long to pull gold out. But if you got serious good amounts of silver, you would be remiss not to pull it out. It will also take copper into solution as well, and we have ways of dealing with that. If you have a lot of copper in your ore, the one way to get around that is you add ammonia to your solution, and the ammonia will prevent the copper from mixing with this, and we'll get into some more why that's important. So we got copper, we've got gold, we've got silver, we got cyanide. Oh, what do you do with it? Obviously you don't want to boil it off. You end up dying that way. So what you do is the second step of the Merrill-Crowe process. You got your pregnant liquor here, full of gold, and you need to get it to plain old gold. What there is are a few steps in between here. What you need to do though first is where this papoose comes in. Cyanide likes to react with aluminum, which this is. Stainless steel vessels of this size, this one's 15 gallons, are fairly pricey. What you need to do is pull the oxygen out of the cyanide solution. Because what you're going to do is, to get the gold out, you're going to precipitate it or cement it using zinc. Zinc loves gold. Gold loves zinc. So what you do is you add powdered zinc to your pregnant solution that has been de-aerated. That will then form a gray precipitate or gray cement. It's nothing really exciting. That takes place pretty quick too. So how does that apply in a practical sense to us? What we're going to do then is take our pregnant liquor, put it in a container that will fit inside of this, use a vacuum to pull a vacuum on it, and then we're going to measure the amount of, back up. What we're going to do first is figure out what our oxygen levels are going into this container using an oxygen meter. I've got a nice old X-Tech here I brought for $300. Once you have that, you can pull the vacuum on it. This will hold the vacuum. It'll pull most of the oxygen out of solution. I don't know how long that takes as of yet. We have to determine that experimentally. And using this, So, pull it out of a vacuum for X number of hours, minutes, I don't know how long yet. Measure the oxygen content going in, measure it going out. Once you've got it pretty low, then you're ready to drop the zinc in. Because although zinc loves gold, the zinc also, it gets very sexy. It looks at the oxygen and goes, oh baby, sexy oxygen. And you end up with zinc oxide, which does nobody any good. And basically wastes a whole lot of zinc, which isn't exactly the cheapest thing. So you end up with the zinc oxide over here. No good. So then you want to pull the oxygen out. Now we have a de-aerated solution. We put our zinc in there. This also is where the assays come into effect. At this point, you would know I had the 0.5995 amount of gold as far as percentage left over, or ounces per ton left over. You know that. You know how much volume by weight of concentrates you put into the cyanide solution. Based on these, you know exactly how much gold then should be in this solution now by weight. Using that weight measurement, you then figure out how much zinc you need, X amount here of zinc, to pull out that gold to get it pretty close. You're always going to use a little bit extra, but you're going to know now by using how much you put in, by your concentrates, what your concentrates assayed at, let's say, and then using that, you get your amount of zinc you need to drop into this de-aerated solution. That will then produce your gray precipitate. Next step is then to filter off all that precipitate using coffee filters and what have you. The big guys or larger mines will use these big, nice filter presses, shoots all the cyanide through there. Your zinc drops out, and then you have this nice, ugly gray powder that's worth tens of thousands of dollars. From there, though, you get the gray, you get the precipitate, but then you also get your cyanide left over. You have some cyanide, that's not a C, not a G. Get your cyanide left over. This can still be reused. Using your test strips and testing mechanisms, you can figure out how much cyanide's in solution to get you back to the level of cyanide you need to do the process all over again. This precipitate, then you smelt it, and your gold shall be there at the end of the day. If there's any spot where these numbers don't match up to what you should have, you know you've got an issue somewhere. Using the cyanide process that we're going to use, it's kind of an aggressive cyaniding process, using a little bit of heat to get the solution to about 35-40 degrees centigrade. So fairly warm, and 30 is about the sweet spot. You can go a little higher. Get the solution hot, use an excess amount of cyanide, 20, well, we won't get into that, but use a little bit of extra cyanide. Using that, proper de-aeration, we're looking at a recovery of between 95 and 99% of all the gold you had in the ore at any point in time. So using the chemistry, we can grab that other 0.45% at least, up to 99% of the gold out of solution, rather than losing, back up, we'll say. If you do gravity, you get 50%, maybe 60%. For every 10 ounces of ore you mine, you've thrown away 4. With this, for every 10 ounces of ore we mine, we've lost a fraction. For every 100 ounces we mine, we've lost 1. But that is an acceptable amount of loss, because to get to to get above 99, it's a law of diminishing returns. It takes so much time, and you have gold just sitting there locked up in your process or in your milling, and it does nobody good. Easier to get this to 99%, and you're going to lose 1%. We're good at that, no problem whatsoever. That's what we're shooting at, is 99%. So that's pretty much it. Got to use vacuums. This is basically our starting off system here. I mean, it holds a 5-gallon bucket, fantastic. So that's this little pregnant solution that will get on the back end. I figure we can process this pretty quick. These stock pots go up to 200 gallons, so they're pretty monstrous things. Not 200 gallons, 200 quarts, 40 gallons, 50 gallons, whatever. I can't do math today. So they go up to quite a bit larger size. The stainless ones are really pricey. So what we're going to do is use probably the best sized stock pot that we can find, that we can cut down a plastic container and drop it inside of this. Because instead of using zinc, you can also use aluminum to precipitate gold out. With these being aluminum, the gold will adhere to the actual pot and will stick into the pores, and you're losing gold on this. And the cyanide will actually kind of eat this a little bit as well. So we're going to put a plastic container inside of one of these. I need to figure out what size works best with the 35-gallon plastic drum. Based on the dimensions, we can just drop a little insert inside of here. Once it's done with the precipitation, the Merrill-Crowe cementation process, we'll then just pull the solution out. We should have a little bit of a sludge on the bottom that has the gold in it. We can then pour either lift the inside out or pour it out, get that sludge out, wash it out as we need to, filter it, and then go into our drying process before smelting. So that's kind of where we are. You could probably also run a couple of these in series off of one larger vacuum pump. The trick would be, of course, this thing's got about a 1-inch acrylic top. If your seals aren't good, it'll be really tough to get multiple ones of these to seal tight off of one pump. Maybe use 2 or 3. But I've got a way to make this work, I think. Using some different rubber gaskets I can buy online to get that seal going good. And once you've got that, you can run, cat again. You might have multiple tanks run at the same time, so you can run, you might be looking at 50 tons of ore you're running that you can still do inside of a shed as far as this goes, is pulling out the gold in the Merrill-Crowe process. But that's how you get your microscopic out. You got to use good old chemistry. If you don't know chemistry, stay the heck away from it. You don't want to mess with it. If you do it wrong, you die. If you do it right, you don't die and you're kind of rich. So it works out good for us. We did go up to the mine this weekend. We'll update on this. We went up to the Goodyear this weekend. Blocked out or did some more mapping. It's not the exciting part of gold mining, but it is a necessary portion of it. We're mapping and surveying. We found another trend that we weren't 100% sure of. We're able to measure out some of the ore body. Know we're in good shape there as far as how much we've got sitting in just one area of the mine. We're pretty happy with it, to say the least. Really excited about this mine. We have another one up there we're looking at right now. We just kind of popped onto our radar by accident. We're going to take a good hard look at that one, see if we're going to claim it as well. We're kind of like vultures when it comes to good abandoned mine claims. If there's potential there, we want to grab it, look at it. We might not be able to get to it for a couple of years to actually start mining, but it's worth sitting on for $255 or whatever it is, the re-up fee to be on for a couple of years just to see what it is down the road. Because we got 4 properties now. But that's it as far as updates. Just wanted to give you kind of an overview on the Merrill-Crowe process and how you get that microscopic gold from out of the rock to into your back pocket, baby. Until next time, folks. Adios.